I bet you've felt this exact confusion before. You're using an app, it looks totally modern and up to date, but then it does something that just feels, well, broken. We're going to break down exactly why that happens, focusing on one very specific, very common moment.
Okay, so picture this. It all starts with a really simple action. You've just updated something. Let's say it's your profile picture. You've just given the system brand new information.
And naturally, you expect to see that change right away. So you hit refresh or you go back to the page, ready to see your new photo.
But nothing happens. The software shows you the old information. Your old photo is still just staring back at you. It totally feels like the app ignored you, like it's broken. But here's the thing, it isn't.
And that brings us right to the heart of the problem, this obvious mismatch. It's the gap between what you logically expect to happen and what the software actually does. So let's focus only on why this happens.
On one hand, you have your expectation. You should see the newest information. But on the other hand, you have the software's reality. It's still showing you the old information. To get why, we need to peek under the hood at how the system is built to handle data.
The entire explanation really boils down to just one core idea. The system keeps a copy. And once you get this, you'll understand so much more about why the internet works the way it does.
You know, for an app to be super fast for millions or even billions of people, it can't go all the way back to the original source for every little thing. Instead, it relies on what's called a local copy, a version of the data that's stored way closer to you.
And fetching that nearby copy is just so much faster. It's kind of like the difference between grabbing a book that's right on your desk versus having to fly to a library in another country just to read it.
Because yeah, going all the way back to that original source takes a lot more time and energy. If every single click had to do that, the whole system would just grind to a halt.
Okay, so if the system is using a copy, how does it decide when it's finally time to get a new one? Well, it turns out the copy just follows one very, very simple rule.
Every local copy that gets made has something called a freshness lifetime. Honestly, you can just think of it like a best before date on a carton of milk. For a certain amount of time, the system says, yep, this copy is fresh, it's good to go.
And a lot of the time, that rule is just a simple timer. You might see something technical like this, max age 3,600 seconds. All that's really saying is, hey, this copy is considered fresh for 1 hour. After that, it's stale. It's just a simple instruction.
And here is the most important part of this whole thing. As long as that timer hasn't expired, the system does not check the original source to see if anything has changed. It simply trusts its copy. Its only job is to do one thing: look at its own local copy and check the timer. That's it. Has the freshness lifetime run out? It's a simple yes or no question.
So the system's logic is actually incredibly simple and fast. It just asks itself, is my copy's timer expired? If the answer is no, it uses the copy. It doesn't need to look any further.
And that simple rule reveals this huge, fundamental trade-off that's at the heart of how these systems are designed. It's this constant balancing act between speed and being perfectly up to the second current. See? By using a local copy, the system gets a massive advantage in speed. It's basically giving up being perfectly correct in every single moment to gain the ability to respond to you and millions of others almost instantly.
And this is absolutely intentional. This system is designed to be fast, first and foremost, not to be perfectly current down to the millisecond. That's the choice it's making. All right, so let's connect all of this back to your original confusion with that profile photo. Why did this system feel like it was wrong?
Well, when you uploaded your new picture and then refreshed the page, the very first thing the system did was look at its local copy of your old photo.
Then it checked the freshness lifetime on that old photo's copy, and it saw that the timer was still active. So from the system's point of view, the copy it had was still perfectly fresh.
And because its number one rule is if the copy is fresh, use it, that is exactly what it did. It showed you the copy it already had, the old photo. It was actually operating perfectly, just as it was designed to.
The mismatch, the reason it feels so weird to us, is because our human intuition expects a direct, live connection. We think, I just gave you the new information, so you should know about it. But the system isn't built on one single direct link. It's actually built on this massive distributed network of fast temporary copies. And they're all just following that simple timer rule to handle billions of requests without falling over.
So the software wasn't broken, and it didn't ignore you. It was just following its most important rule: prioritize speed by using a fresh local copy. And That right there is why the app looked up to date, but it still showed you old information,